Hello students, welcome to the next session. So as you have seen in the last class, so we have gone through the what is resolution, right? So resolution with respect to the propositional logic, and also we have seen the steps how we are going to follow with respect to the FOPL, that is the first order predicate logic. So we have seen at an example how we are going to do resolution in FOPL. Now let us in today's class let us take some other examples and we will try to see in more detail now how, and also we will try to look into the algorithms. Now if you look into the propositional logic, that is already we have seen in our previous class. Now if you go to our propositional logic, let us look into the algorithm what it says. Now if you look here, now what is the propositional logic algorithm is telling us? Now it clearly says that now convert all the proposition of f to the class form, right? The first thing what you are supposed to do is that, now the first thing what you are supposed to do is you have to convert it into the classical form, right? So whatever the WFF or the proposition you are having, so you have to convert it in the class form. The second one is negate P. That is what you want to prove as far as the resolution principle. Suppose say that if you want to prove P, now you are going to convert that result to a class form. So the statement what you want to prove, again that also should be converted to the class form, add it to the set of all the classes which you have obtained in the first step. Now say for example, you have given some 5 facts, right? Now what you are going to do is that now all these 5 facts you are going to convert it into the class form. Now that is your first step. Now after converting into class form, you want to prove P. Now if you want to prove P, now you have to convert this P also to the class form and you are going to negate this, right? So as far as the principle of resolution, so you are going to negate this P and add that also into your, what you can say, the database or the knowledge base. So then we are going to start our process. Now what it tells is that negate P, convert that result also to class form, add it into the set of all classes. The third step says repeat until either a contradiction is found or no progress cannot be done. Now you are supposed to follow the principle of resolution. Now what we are going to do is select 2 classes. We are going to call it as the parent class. Now say as we have seen in the example, now suppose say that if these are the facts in our knowledge base, and if you want to prove R, now we are going to negate this R. First step is that you are going to convert all this into classical form. That is, you are going to remove all the implications, move the negation to the individual terms, and see that it is in conjunctive normal form. So after doing all this process, now you are going to select 2 classes. So you select 2 class, we call it as a parent class. So then resolve them together, and that resultant class is called the resolvent class. Now say for example, now if you consider, now you have got one class P, right? Now you have got another class, let us say negation P or T. Now these 2 you can call it as a parent class. Now you are going to resolve these 2 class. So when you are going to resolve these 2 class, that is when we are going to get a resolvent. Now this resolvent will be the disjunction of all the literals of both the parent classes with the following exception. Now it will be a disjunction of all the classes in this one as well as this, because right now we have got 2 parent classes. If there are any pairs of literals L and negation L such that one of the parent class contains L and the other contains negation L, then select one such pair and eliminate both L and negation L from the resolvent. Now what this step says that, now when you are going to consider here, now both of these classes, so now you have got this class P and you have got negation P or T. Now you see that here, now we have got P and negation P. Now this P and negation P cannot go simultaneously, hence these 2 cancels with each other. So now we cancel this P and negation P, and the leftover is T, right? So we will write T as our resultant class. So we are going to write T as our resultant class. So we come, then we are left with the, again select any one of our class from our knowledge base. you can consider, say for example, you have got P or negation. Let us say, so we have P and another case, let us say that we have again P or negation T. Now what we can do, now you have got T here and negation T, you can cancel these two, so we can resolve this. Now when you cancel these two, so we are left over with P. Now like this you keep on doing it until you get the contradiction or empty class, right? So that's it says, third step says that if the resolvent is an empty class, then a contradiction has formed. Now if you keep on doing and if you get an empty class, so what it tells that we started with a negation P with a contradiction, so it is not, if it cannot be there. So since you started with, you want to prove P, you started with negation P, end up with an empty set, so that means P is true. So this is how the resolution principle says, and this is what we have already discussed in our last class with this particular example. So now let us look into another algorithm which is called as unification algorithm, right? So it is the process of unification. Now why this why the unification is very important for us? Clear? So now in propositional logic, it is easy to determine that two literals cannot be true at the same time. As we said that if you are having two classes, one is say that A and the other one is negation A, both cannot go simultaneous. So we are going to cancel this and get a resolvent class. It is easy in our propositional logic, but when we go to the predicate logic, now it is very difficult. In predicate logic, the matching process is more complicated. So why it becomes complicated is because we have got variables. Now there will be some of the variables will be there. So it is not easy for us. So it is not just like we have got A and negation A, so both can cancel, so that we are going to resolve two classes. Suppose say that in predicate logic, now we have got one predicate P of X is there, the other predicate is that negation P of Y. So here we have P and negation P, but inside the variables are different. Here X is there, Y is there. You cannot directly resolve it. You cannot cancel this because one is X and one is Y. So we need, so when we are talking about our predicate logic, the matching process becomes very complicated because it is binded with some variables. So in order to determine the contradiction, we need a matching procedure. So now it is very clear. Now if you want to cancel this P of X and negation P of Y, now either you have to convert X to Y, that is a variable, you should change X to Y, or you are going to change this Y as X. Now if you rename this Y as X, then you read what we are having, P of X is 1, negation P of X, so you can cancel both. So this particular substitution or matching procedure that compares two literals and discover whether there exists a set of substitutions that makes them identical. Now if I want to make the both identical, then I have to substitute X in place of Y. Where all Y is there, if I substitute it with X, so then only I can do the matching. So this is called as unification. So we are going to unify the variables. So this algorithm, we call it as a unification algorithm. So it is a recursive procedure that do this matching, right? Now the process of finding a substitution for predicate parameters is called as unification. This process we call it as the unification. Now let us see how we are going to do this particular process, or what is the algorithm we are having. Now what it tells, now initially initial predicate symbol must match. So that means you have to match with the predicate symbols. The first thing you are going to look at with your symbols. So that is what we are saying. Say for example, you have got P of X, right? So now one is you have got P of X. The other predicate also should start with P. The predicate should match. So you cannot say that one is P of X and the other one will be like some other predicate. Say for example, if one predicate Marcus is a man, and other predicate will be negation Roman. Marcus is not a Roman. Now here this predicate is man and this predicate is Roman, it is not matching. It both the predicate has to match. The first is the initial predicate symbol must match. Then for each pair of predicate arguments, now whatever the arguments we are having here, now different constants cannot match. Right? We are going to look into the arguments. So you might be having different type of arguments. Some may be constant. You will be having a variable. Now variable may be replaced by a constant. Wherever a variable is there, now you can replace a variable by a constant. A variable may be replaced with another variable. So when you have got constants, different constant cannot match, right? Whereas variable, it may be replaced with a constant or another variable. A variable may be replaced by a function, as long as the function does not contain an instance of a variable. Now all these things we can try to do in our unification process. Now let us take an example, or let us see some of the examples now how this substitution process is being done or unification is being done. Now if you take here the first one, what we are having now, p of x, right? So you have got p of x, the other one is p of y. First you see both the predicates. Now both the predicates are same, it is matching. Here also p is there and here also p is there. But to make both, one is x and the other one is y. Now if you want to make both, so you are going to replace that what we are saying. So we write it in this particular fashion. So x bar y. We are going to substitution x for y. So wherever y is there, in place of y you are going to replace x. So then what this 2 becomes now, one is already p of x, the second one p of y. So now what we are trying to do, we are going to, wherever y you are having, you are going to replace it by x. So then this also becomes p of x, right? So this is how we are trying to do it. Now say for example, now if you take this one, the third one, now p of f of x. Now here f of x is one function inside our predicate, and next one is p of x. Now you cannot replace this function f of x, you cannot replace this function f of x by just x, because it is a function. If it is a variable, you can try to do it. So this method is there. Now even you can say here, if you take this example, you have got p of x or q of Jane and p of Bill or q of y. Now if you want, now you see here, now if you want to do like say resolution, and if you want to resolve, so then first thing is you are going to look into the predicates. Now you see the first predicate we have got p of x. Now another predicate p of Bill is there. Now both the predicates are matching here, but only here x is there and here Bill is there. Now what we can do is that now we can replace the Bill with x. So if you replace Bill with x, then this becomes x. Now we have got p of x, both are same, right? If suppose say that if you have got any and symbol here, negation, then both can be cancelled and we can try to resolve it. We can go to the next step in our resolution. So this is what we are going to call it as the process of unification. Now when you look into this unification algorithm, what it says, so here we have got some of the examples which you can go through it, the slides later. Now when you look into the algorithm, because sometimes in the exam you will be having question which asks explain the algorithm of unification with an example, or they may ask explain the algorithm of resolution. So algorithm is also very important to understand. Now if you look into the algorithm here, now let us say what the algorithm or how what it says. Now it says that now unify L1 comma L2. So you are taking two literals and you want to unify both the literals. So obviously you need two will be the arguments what we are having. Now the first step says that if L1 or L2 are both variables or constant. If both are variables, so then if L1 and L2 are identical, if both are same, so if you are taking that both are variables, say one variable is x and the other variable is also x, and both are already identical, then there is no question of applying this particular algorithm, so we are going to return nil. Else if L1 is a variable, then if L1 occurs in L2, then return fails. So if L1 is a variable and if already that itself occurs in L2 also, in literal also, we are going to return fail. Now else, so we replace this L2 by L1. So if it is not, then we are going to replace the L2 by L1. So if one is X and the other one is Y, then we are going to replace this Y with X, so that you try to do the unification. Similarly, both with vice versa. If L2 is a variable, then if L2 occurs in L1, so then we return fails, else we replace L1 by L2. This is the first step when we have got only variables. Now second step says if the initial predicate symbol is, now if we are talking about predicates, if it is L1 and L2 and both are not identical. So if you have got a predicate, one is P of X and the other one is Q of X, and both are not identical, one is P and one is Q, you cannot apply the resolution, so we will return fail. If L1 and L2 has different number of arguments, then we return fail. If arguments also should be the same, not only you are going to look into the predicates, you are going to look into the arguments also. Arguments also should be the same. Now in one you have got one argument, in other you have got two arguments, again you cannot do your unification process. Right? So one by one we are going to look into the steps. Now next is set subset to nil. So now you want to unify, then we take a subset and initially it will be empty. So then what we try to do is for I 1 to the number of arguments in L1. So how many arguments are there in this? So we take, now we call the unify, that is you call the same algorithm recursively with the argument of L1 and the ith argument of L2, putting the result in yes. That means each time when you are calling, so you check this argument. Now if both predicate matches and if the argument is also, the number of arguments are also same, then you keep on replacing that particular, the other variable which is present is in the first literal. So then we try to do this, and we try to, whenever we are trying to unify that, so we add it into this particular subset and we try to append that particular subset. So this is what the unification process or unification algorithm says, right? So still here we have got some of the examples which you can go through this particular example. So now we are talking about the algorithm of resolution in predicate logic. Already we have seen this particular, what is the concept of predication with an example. Now we'll just try to understand the algorithm. What the algorithm says, so as you know that convert all the statement of F to the class form. So you are going to convert all the statement, whatever the WFF you are going to consider, convert it into the classal form. So that is your first particular step. So once you have converted everything into the class form, so we know that when converting into the class form, now what all the steps you are supposed to follow, we have already studied. The first step is what? To convert it into a class form, you are going to remove implication and double implication by using the suitable formula. The second step is the move all the negation to the individual term by applying your De Morgan's law. The third step is that standardize the variables. See that you have unique variables with all the predicates what you are going to consider. So the next step what we discussed, you are going to eliminate the existential quantifiers. So the fourth step is move all the quantifiers to the left hand side, then remove existential quantifier. If you have got any existential quantifier, so you are going to remove it by a process called as Coulomization. So after that, now you are going to check whether it is in conjective normal form. Apply the distribution law properly and try to see that it is in conjective normal form. And the last step is you are going to drop all the AND symbol, and each one we are going to consider it as a class. So these are all the steps which you are supposed to follow to convert the given WFF to the class form. So that is your first step which you are going to do it. So once you have done this particular step, the next is what you want to prove. So the negate P. You want to prove P, negate that P, and the convert that result also into the class form, add it into the set of all the classes what you are having. That means your knowledge. The same steps what you have seen the algorithm for proportional logic, the same algorithm, that is the resolution algorithm, holds good for our predicate calculus also. And the third step, repeat until a contradiction is found or you are not going to further proceed. So what you are doing, select two classes, call them as the parent class, resolve them together, and the resolvent will be the disjunction of the literals of both the parents. Like when you have got parents as T1, negation of T2. Now such that one of the parent class contains T2 and the other contains T1. And if T1 and T2 are unifiable. Now you can see here, if you have got one class T1, the other class is negation T2. Now you are going to call your unification algorithm. So already we just now discussed. So you are going to call unification algorithm. Now if this can be unified, that means if this T2, if you can be replaced with the T1, then you have got T1, negation T1, both can cancel. So you can apply the concept of resolution. Now check whether these are unifiable. Then if it is not unifiable, if you cannot resolve, then you have to consider some other class and keep on doing the step until you reach an empty set. If the resolvent, once you reach an empty class, so then a contradiction has been formed. And this is how you have the algorithm for resolution for our FOPL, that is first order predicate logic, right? So this is the algorithm, so which was pending, which we have discussed. So now this example already we have seen. Now let us take, and that is how we have done this resolutions. Now we will try to understand this particular example. So now already we have given some facts are there which has been represented in FOPL. Now we are going to convert it into a class form. So these are all the statements which is already converted into class form. Now what we are supposed to do, now we need to prove Marcus hate Caesar. So what you are going to prove? So you need to prove this statement. What is that statement? So Marcus hate Caesar. So this is what you need to prove. So now what we want to prove, that also should be converted into class form, right? So now we will convert it into class form. So which is that hate Marcus comma Caesar. So this is the class form. So there is no implication, there is no negation, so all those steps is not required. So directly we have converted into class form. So we need to prove this. So Marcus hates Caesar. So now we apply the principle of resolution. So we are going to negate this. So since we need to prove Marcus hates Caesar, now we are going to negate it. So negation of hate Marcus comma Caesar. Now we will start from here. Now we will look into our knowledge base. Now these are all the knowledge base now which is already present in a class form. Now we are going to apply the resolution. Now from this knowledge base, since now we are starting, right now we have got hate. So let me just clear it and we'll try to once again do these things. Okay, so now let us start it. So now what we are starting with negation. So we will take negation hate Marcus comma Caesar. We are starting our resolution. So now here we have got hate. This is the predicate hate. Now from my knowledge base, now I will check such that I can apply the concept of resolution. Now you can see in the first class we don't have hate. Here Pompeian is there. Now if you keep on looking, now you see that in my fifth class there is hate, right? So now I will consider my fifth class and we try to do the resolution. We apply to the resolution. Now if you look into our fifth class, now here you see hate x2 comma Caesar is there, but what is the arguments here we are having? Marcus comma Caesar. Now this predicate hate and this predicate hate matches. Now we are using the unification. We have to apply the algorithm unification here. Now both the predicate matches hate and we have got inside the argument we have got Marcus and Caesar, but here we have got x2 comma Caesar. So now what we are going to do, if we are able to replace this particular x2 with Marcus. So you know, if I replace, so I will write like this. So Marcus with x2. If I replace this x2 variable with this Marcus, then what this becomes? Now this becomes hate Marcus comma Caesar. So now this becomes hate Marcus comma Caesar. We have got here negation hate Marcus comma Caesar. Now both get cancels. So we resolve and get a new class. So what will be my new resolvent class? The remaining classes will be my resolvent class. Now I will write on that remaining classes. Now what are the remaining classes we have got? We have got negation Roman x2, but x2 is been replaced with what? Marcus. So we are going to write it here Marcus, or the next one is loyal to x2 is replaced with Marcus. So we will write Marcus comma Caesar. So now we have resolved. So now this won't come in my resolvent class because this is cancelled, because hate Marcus comma Caesar and negation hate Marcus comma Caesar cannot go simultaneously hand in hand. So now I have got a new resolvent class. Now again I will start the principle of resolution. Now I will check any of my literals can be cancelled. Now you can see here, now we have got negation Roman. I will check anywhere can I get the Roman, so that I can cancel this negation Roman. Now if I consider here third one, now you can see here we have got Roman of x1, but we have got Roman of Marcus is there. So now I will take the third fact, that is the third class what is there in our knowledge base. So we are going to take my third class. Now what is our third class is there? So we have got negation Pompeian of x1 or Roman of x. So with these two, now we try to do the resolution. Now if I want to cancel this negation Roman of Marcus, and this is the third one we are considering, that's why we are written here 3. So Roman, now I have to do unification because here x1 is there, but I need Marcus. So now what is that we are going to do? We are going to replace the variable x1 with Marcus. Now if you replace the variable x1 with Marcus, now what it becomes? Roman of Marcus, here negation Roman of Marcus. So this and this cancels. So now we are left with the new class, that is the resolvent class. Now you write down this that particular resolvent. Now what is that resolvent? We have got negation Pompeian of x1. What is x1? Marcus. We have replaced it x1 with Marcus, and also previous one. This is already left, so we'll get back this as it is, or loyal to Marcus comma Caesar. Right? So now this is the resolvent class. Now again, now we are going to check. Now can we try to resolve? Now you can see you have negation Pompeian and you have got loyal to. Now you try to see anywhere again if you are able to get any literals in our class, so that we can try to cancel those things. So now if you see now this second class, now if you take here second, you have got Pompeian of Marcus, we have got negation Pompeian of Marcus, so easily it can be cancelled, right? So in the next step, so we will take this class 2, we are going to take our second class and we try to do the resolution. So when you take, so Pompeian of Marcus, negation Pompeian of Marcus, it cancels with each other. So we'll get a new resolvent class. Now what will be our new resolvent class? Loyal to Marcus comma Caesar. Right? So now we are getting the loyal to Marcus comma Caesar. Now further, now we are going to consider. Now again we should cancel, try to see here. So loyal to Marcus. Now when you look here, can we try to cancel loyal to? So if you look these statements, so where loyal to comes. Now here you can see in fifth one we have loyal to, but we don't have negation symbol, so we cannot cancel. Now you look into a seventh one, here we have got negation loyal to, right? You can see the seventh class. So negation loyal to is there, here loyal to, so we can cancel these two. So now we try to consider our 7th class from our knowledge base. So we consider our 7th class and we try to resolve these two. So now what is there here? Now negation loyal to x4 comma y1, but we have got Marcus comma Caesar. So now what? First Marcus, that means in place of x4, if Marcus is there, then matching will be done. So we are going to replace our variable x4 with Marcus and we will be replacing y1 with Caesar. y1. So if you replace x4 with Marcus and y1 with Caesar, so this and this becomes same with here negation is there, here we don't have negation, so it cancels with each other and we will get a resolvent class. Now the resolvent class, what will be there in our resolvent class, the remaining comes into our resolvent class. So we will write down that. So what are the remaining literals we are having? The first one is negation man of x4. Now what is x4? x4 is Marcus, so we will write Marcus, or negation ruler of y1, so y1 is Caesar, or negation try to assassinate, or negation try to assassinate x4, that is Marcus comma Caesar. This is the resolvent class what we have got, right? Now again we'll check our knowledge base. Now if you take the first one, so we have got man Marcus, here we got negation man of Marcus. So if you consider the first class from our knowledge base, now we can easily cancel these two classes. So if you consider the first one and try to do the resolving between these two, so now this cancels, so we are left over with negation ruler of Caesar, or negation try to assassinate Marcus comma Caesar. Now again we'll check into my knowledge base. Ruler, negation ruler is there, anywhere ruler is there, so that I can try to cancel. So we have got fourth here. So fourth ruler of Caesar, negation ruler of Caesar. So if you consider your fourth one and try to further negate, so that is further apply the resolution. So if you consider fourth one, ruler of Caesar, right? Negation ruler of Caesar, both get cancelled. So we are left over with the new resolvent class, which is negation try to assassinate Marcus comma Caesar. Marcus comma. You keep on doing this. That's all. It's very simple. Keep on doing it wherever you need. You try to do the unification. So now you have got negation try to assassinate Marcus comma Caesar. Now you see the eighth one. So what you are having? Try to assassinate Marcus comma Caesar.
Class sir.
Recording.
One ನಿಮಿಷ ಟೈಮ್ ಟೇಬಲ್ ಈ ಸಲ ಏನು ಮಾಡಿದೆ ಸರ್?
ಆಮೇಲೆ ವೆರಿಫೈ ಆಗಿದೆ ಅದು.
ಅಲ್ಲ ಕರೀತಾ ಇದ್ದಾರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಈಗ ನಿಮ್ಮನ್ನ ನಾನು ನೋಡಿಕೆ ನಾನು
ಫಸ್ಟ್ ನಾನು ಮಾಡಿದ್ದು
ಈಗ ಕರೆಂಟ್ ಸೆಮಿಸ್ಟರ್
Okay, so the last when you're looking here, so negation try to assassinate Marcus comma Caesar. So you take your last fact from your knowledge base, try to assassinate Caesar. So if you take eighth one and if you further try to do the resolution, so both cancels and we are going to get an empty set, right? So now we started with, when you look into our resolution, we started with negating what we want to prove. So we wanted to prove that Marcus hates Caesar, so we took the negation and we came to the contradiction. So hence we can say that the Marcus hates Caesar is true. Clear? The same thing is given in this particular diagram right now what we have done. Now let us take another example and we'll see how we are going to apply the resolution. So now this is a very simple example. So what it says, we are going to convert all the given WFF, right? Convert, the first one is convert all the above statement to predicate logic. Show that John likes peanuts. So using back chain, so we will not discuss this right now. So we are looking into only the resolution. Now the third one is you have to convert the statements into class form and use resolution and show that John likes peanuts. Okay. So now, so what are the examples? Now what are the fact given for us? The first one, the fact given is that John likes all kinds of foods. Apple are food, chicken is a food, anything anyone eats and it is not killed is food. Bill eats peanuts and is still alive. Sue eats everything Bill eats. So the first question, convert all the above statements into predicate form. So now if we take the first statement, so John likes all kinds of food. So we have got all kinds. So what we are going to say, for all x, all kinds of food, right? So for all x, where x is food, where x is food implies that who likes, John likes. So like is the predicate John. So this is the first one, right? We have converted into predicate logic. Second one, apples are food. It is very simple. We will take food as a predicate and in bracket apple. Similarly, chicken is a food. The third one, anything anyone eats. Now you can see here anything, anyone. There are two universal quantifiers. So we say that for all x, for all y, eats. Anything anyone is going to eat. So eat will be a predicate who x comma y. If x eats y and it is not killed, right? So if I take predicate as killed and if x is not killed, so we'll put negation, x is not killed implies that it is a food. Which is a food now? Y is a food. So we are quantifying this x to a person and y to a food. So it implies that y is a food. The next one, if we take Bill eats peanuts and is still alive. So Bill eats. So eats is a predicate. So we are going to say eats. Who is going to eat? Bill eats peanuts and is still alive. And alive. Alive is a predicate. Who is alive? Bill is alive. Right? So it's very simple. Similar to the last one. Sue eats everything Bill eats. So we say that everything. Since here we have got everything, so we'll say for all x. What is that? If Bill eats x, right? So everything for all Bill. So Bill eats x implies that Sue also eats that x. So this is how we are converting the given statements into predicate logic. Now the next step is that you have to convert the statements into class form. So as we know that we are going to convert it into a class form. So you take the first one. Now you are going to remove the implication, right? So in this you have implication. You know that if you have got A implies B, you use the formula negation A or B. So this is the formula which you are going to use it. So we will use that particular formula and we are going to write. So this becomes negation food. So when you take the first one, this first one when you take to convert it into class form, so we can say it as for all x negation food of x or John like. That is the first step, remove the implication. Second step, move all the negation to individual term. Already it is in the individual term. Third one, standardize the variable. So now only one x is there, so we don't need that particular step also. Move all negation to left hand side. Eliminate existential quantifier, right? So we don't have any existential quantifier. That step is also, it's gone. So next what we say, remove all the universal quantifier. So if you remove all these things, so you are going to get negation food of x or John likes food. So this is what we got that result after converting into class form. If we take the second one, apple is a food, so no need to do, it is already in the class form. The third is also in the class form. Now the fourth one, right? So you have to take this, now you have to remove this implication. So when you remove this particular implication, now this is what we are going to get. So negation eat of x comma y and negation killed of x or food of y. So implies is there, so we are putting negation a or b, right? So then we bring this negation to individual terms, so that is negation eat of x comma y and becomes or negation cancels, it becomes killed of x or food of y. This is the final Clausian form. Next is eats, Bill eats peanuts and, so already it is in conjunctive normal form. We can drop this and we can make it as a two things. One is the Bill eats peanuts and Bill is alive. We add it into our causal form. And the last one, this is how we are converted. So now we have converted everything into the class form. So now we need to prove. Now what we are supposed to prove? We should prove John likes peanuts. So what is that? Now you are going to say, so you are going to prove like John comma peanuts. That is John likes, you should prove this. So to prove this, we will negate this and add it into our knowledge base. So we are going to start with negation of like John comma peanuts. So now in our class we will see which one we can try to resolve. Clear? So which one we can try to resolve. Now you keep on comparing. Now we have got likes, so you see anywhere likes is there. Now in the first one you have got likes John comma x, right? Here also negation, so you can cancel these two. But to cancel these two, these things should be same. Here we have got John comma x, here got John comma peanuts. That means you should go for unification. What is that unification? We are going to replace x1 with peanuts. So when you replace x1 with peanuts, so this and this get cancelled. So we are going to get the resolvent class. So what is our resolvent class? Resolvent class will be negation, right? So resolvent class will be negation food of x is replaced with what? Peanuts. So negation food of peanuts. Now again you check, can we cancel food of peanuts here? Negation food of peanuts. So we have got here food, but apple is there, so we cannot, it is a constant, you cannot replace apple with peanuts, right? Unification you have seen the first step. Whenever there is a constant you cannot replace, neither you can replace this. But if you take this one, the fourth one, here you have got food, killed and eat, right? So now you have got food of y is there. Here negation food of peanuts. Now you can replace y with peanuts and we can cancel these two. So you are going to replace y with peanuts. Consider your fourth predicate. So now this gets cancelled, food and negation food. So we are left with these two are left with our resolvent class. So that's those two becomes our resolvent class. So now we will write that particular resolvent class. So what that will be? Negation eat of, so now x, right? x2 we are writing y. So you know that y is replaced with peanuts. So x2 or x comma peanuts or killed of right, killed of x. Now here there is one particular thing. So now what we have taken, not alive. So we have modified this killed of x, right? So when you consider now this predicate, now killed of x. So killed of x means, so we can even think that kill means it is dead. right? Or in order to get our resolution, we are slightly modifying this name of this predicate and we try to add that one. So what we can, it is modified as alive. We know that already we have taken alive here, right? See, here we have will alive. If he is killed means he is not alive. So now this killed of X can be replaced with negation alive of X, because already one predicate alive is there. If you put a negation to that, it is not alive. Not alive means it's nothing but killed, right? Not alive means it is nothing but killed. So here we are going to replace this with, so negation eat X comma Y, or negation alive, that means killed of X or food of Y. So this we are going to add. Now if you add that, so in this step when you cancel this food, so you are going to get this. So negation eat of X comma peanuts or not alive X. So now again if you consider here, so now we can try to again take this particular fifth one. Now we are going to cancel this. Now we are trying to again cancel under this fifth one again. So here now we have added the separate predicate, so that now we can try to resolve and we can try to get this. So we have got alive of Bill. So now we will consider the sixth one here, right? So negation alive and alive get cancelled. To replace this, you should replace X2 by Bill. So when you replace X2 by Bill, so these two get cancels and we are going to get resolvent class is negation eat, X2 is replaced with Bill, so Bill comma peanuts. And finally negation eat, now we have got here eats, right? Eats is there, eat, this we make it as eats. So now we can cancel these two. So by Bill comma peanuts. So Bill comma peanuts both are matching. So when you consider this fifth one and when you try to resolve it, both get cancels and we are going to get an empty cell. Now since now we got an empty set here, now we can try to see that we negated this, that is John does not like peanuts, and we came to a contradiction. Therefore what is the result? So John likes peanuts is true. So John likes peanuts is true. So this is your final result. Clear? This is another example what we have seen under the resolution. So you have to understand that when you are doing the resolution with respect to first order predicate logic, the same method we use what we did in FOPL, but we need another algorithm called as unification, where you are going to unify the variables, make the variables same such that you can apply the concept of resolution. So this is what we wanted to discuss in today's class. So try to solve as much of problems from the textbook so that it will be easy for you to understand. Okay, thank you very much.